Hey everyone, I hope you all are doing good and having a wonderful day. In this video, we are going to talk about how we can fine tune a local large language model with our own dataset so that we can improve its overall efficiency. And since we are a cybersecurity channel, we are going to train this particular model to understand a specific vulnerability. And to be more specific, we are going to train this model to understand more about cross-site scripting so that it can give us more complex payload based on the scenarios of where our user input is getting reflected. But as always, before diving deep into this video, if you haven't checked out my previous video, then go ahead and check it out. The link of the video is given in the description, as well as you can see it at the right side of the screen. And now, with that being said, let us get started. Okay, so before going any further into this video, first of all, let's try to see what is the problem that you are aiming to solve. Okay, so right now I'm going to start my Olama server. We all know that how we can work with Olama. If you haven't checked out more about Olama and how we can use it for our own custom AI agents that can call tools and all, so you can go ahead and check the video. I have already created a video on it, so you can see it right over here, or you can just click on the link, which is also given in the description. Okay, we can simply go ahead over here and just try to run Llama 3.1 8 billion parameter model. Okay, as you can see, some stuffs are going on. We'll wait for a few seconds once it is completed, and then we'll go and use this particular system prompt. Okay, so basically it says that you're an expert in finding XSS on a lab environment. We need to mention lab environment, otherwise we'll think that we are doing something fishy. And then the user is going to give this input, and you need to understand the context of it. So basically, what I want to do is I want this LLM to understand where my user input is getting reflected. For example, it is here, it is inside a single quote, and then it needs to break out of it. So, for example, if we want to break out of this particular example, we need to use a single quote, and then we can go ahead and use some payloads. For example, on mouse over alert one, on error, or on click, or on before key input press, or a lot of event handlers are there, right? So basically, what I need is that I want that model, this model, to understand the context, see whether it is possible for us to break out of it or not. If it is possible, then please break out of it. If not, then try to create a new tag. Okay, and this is like a very normal system prompt that I've given. Okay, so we can let me just give it an example. Let me give this just to make this model. And by the way, guys, if you are new to LLMs and if you want to have more accuracy over whatever task that you are making it to do, you should be giving it few examples. So the more example you give, the more it will adapt to okay, what exactly we are looking for. So the output will be on mouse over equals to alert one. I'm just giving it an example. Okay, then we'll just close the string. Okay, this is pretty much it. You can go ahead and hit enter, and you can see it can provide the guide. And you see, instead of giving me more about what I needed, it is giving me a little more explanation about the vulnerability context. It is also because this has been given as a user prompt over here in this CLI. It is not given in the system prompt. If you do that, then it will be more accurate. But even then, it will not be able to do its best. So let me just stop it right now, and I'll ask it that for find a suitable XSS payload, this particular scenario, okay, for A. So let's assume that my input is getting reflected over here. So we'll try to do this. Name equals to, and this is where my user input is getting reflected inside a script tag. Okay, I just want to show you guys that how exactly this is working and what is the issue that we'll see. And we can just full stop. Let's hit enter. You see it has started analyzing the context. So let's see how it's going to find the payload. Okay, so you can see it has come up with a payload, but if you take a closer look, doing some reasoning in itself. So let's wait and then we'll go to our conclusion. Okay. So as you can see, this is the script that this particular tool has given us. The thing is that I'm still not sure that what is the exact payload, to be honest, because it has given us the whole script, right? Obviously, we're not going to paste it. We want what needs to be replaced from user input to execute the payload. So I'll just ask it that what needs to be replaced with user input to execute the JS code in the context above. So just a little more interaction with it. Text above. Let's see what it will give us. Okay, so again, you can see it is, if you take a closer look, it has given us this particular payload, right? Script alert, script tag close. And I don't know why it has also given us this your input inside the comments, which is obviously something that's not going to work. Even this payload that we're going to enter is going to be wrapped inside the single quotes, right? So even that is not going to work. And again, it is in the next example, it has given us imgsars equals to x on error eval. So again, this is going to break. It's not going to work, to be honest with you, right? Because if you want to execute this payload, what first needs to be done is we need to break out of the single quote, then we need to break out of the object, and then we need to execute the code. But it seems like this particular model is having a hard time understanding the context properly and how to break out of it. This is the reason why we are getting this particular issue, right? Now, this is what can happen if you're using a small model locally into your machine. And to actually fix this, we can simply train this particular model more about cross-site scripting and more about XSS payloads. Okay, so now that you have understood the problem, let's try to go ahead and see that how we are going to solve it. Okay, so let's try to go ahead and fine tune our model. But before that, let me tell you that one of the most, I would say that the most important part for you to fine tune your own model based on your data is to have a very proper data set, which is related to your domain specific task. For example, here our goal is to generate XSS payload. So I should have a data set in which there will be a bunch of, examples given in the format of instruction, input and output about XSS payload. For example, as you can see, the instruction says that find XSS payload that could be injected in the following HTML element, then the input. So this is the instruction that will give, this is the input we are going to give, and this is the output that we are expecting from the model. Okay. And you need to have as many examples of these values as possible. Okay. The more example you have, the better it is going to understand about your domain specific task. Okay. And now that we have the data set, and this is the data set that I have personally created for myself, and I think in your case as well, you will need to create your own specific data set based on what exactly is the outcome that you're looking for from the model. Okay. So see how the data set, what you need to do is you simply need to go ahead and access this particular URL to fine tune your model. Okay. So I have given the link of this particular URL in the description as well. So you can go ahead and simply open it. And once loaded, you simply need to execute all of these. So let me show you how we can do that. But before that, if you want to just use the model which is fine tuned by me for this particular video, you can go ahead and simply copy this URL and you can download it from here. Okay. It's already uploaded on Hugging Face. And now let's try to go ahead and start our fine tuning process. Okay, so now let's try to execute all of this cell one by one and let me explain what each cell is doing. Okay, so first of all, we are going to uninstall any version of SymPy in this particular notebook and we're going to install this specific version which is going to work well for us. Okay, so let's go ahead and execute this. Again, it's all going to take some time. It totally depends on your internet connection and all those stuff. Okay, so you can see right now it is connecting. It has connected successfully. SymPy is getting installed. SymPy, just wait a few seconds. Okay, and as you can see, the installation has been completed successfully. We're going to ignore this error because it doesn't really affect us. Then we'll be importing some necessary libraries. So let's go ahead and import this. So we are going to use unsloth, to fine tune our model using a technique which is known as QLoRa. Okay, I will talk more about it in detail in some other videos, but since this is very related to us training our model, and I'm going to focus on that so that we can stay true to our video. But if you guys need more videos about AI and stuff, just feel free to let me know. So as you can see, it is getting executed. We'll wait for a few seconds and then I'll get back to you once it is completed. Okay, as you can see, this has been executed. We are not going to touch this particular cell. In case if the fine tuning is not working or if you're getting some more errors, you can go ahead and try to execute this cell again. Simply just uninstalling the torch library and installing it back again. Okay, and we have already did this part, so we don't need to worry about it. Scroll down, and this is where we are going to load the model. Okay, and over here you see I'm going to train the Llama 3 model actually instead of Llama 3.1, but it's not going to be an issue because even this Llama 3 specialized on our own domain is going to be much better than a general base model of Llama 3.1. Okay, so you just need to click on this run again. Okay, and this is like, let me just explain it to you guys. This is the 2048 is the maximum sequence length. So basically it's the maximum number of token the model can produce. You can reduce this if you're getting some errors, but generally with Google Colab, this setting should work fine. Okay, and now we can simply go ahead and click on play button again, and this is going to take some time because it's going to first pull this particular model into your local machine, I mean into Google Colab, and then we'll have everything configured. So again, I'll get back to you once this is get completed. Okay, so as you can see again, the process has been completed right over here, and we have successfully downloaded all the necessary files. the model, the tokenizer, and all those important things. Okay, then you need to go ahead and scroll down, and you simply need to execute this again. Okay, and we'll be waiting for a few more seconds here. Basically, runtime you can say, so that we can go ahead and train it. So we'll be waiting for a few seconds, and as you can see, the model is executed as well. And this is where we are going to import our data set. Okay, so this is where we'll be importing the data set, and make sure one important thing that make sure the data should stay in this particular format: instruction, input, and output, and the overall data should be in JSON format. Okay, so let's quickly go to files. Let's go ahead and click on upload. Load here, and we'll go to dataset, and we'll choose this data that I have created. Click on open, click on OK. And now we are going to click on this button. And as you can see, the data has been loaded successfully. Make sure that the data name and the data that you have uploaded is the same. Okay, the name of the data that you have uploaded actually. And we have about 554 rows. And now we are pretty much good to go. The few more steps are remaining. Let's go ahead and click on this. Okay, so it is like loading the tokenizer and all those necessary arguments. I would say not to touch this particular setting. Was very much optimized for the Google Colab in the best way possible. And here we are. The data has been loaded. We'll see how much memory we have. So you can see we have about 6.875 memory still reserved, and out of 14 gigabytes, right? So we are good to go. And the last thing that we need to do is we are going to click on this button, and the training will be started. So let's go ahead and do that. Okay, so now let's go ahead and start the training. Okay, you simply need to go ahead and click on this train button, display button, and it's going to wait for a few seconds. It's going to take some time, and here you are given the option whether if you want to like visualize the training. So you can go ahead and click on use existing WNB account. I mean, if you don't have an account on WNB.ai, go ahead and create it. Okay, otherwise you can also skip this, but I'm going to use an existing account of mine, so let me just go ahead and use that. And here it is asking for me to paste the API key. We need to go to WNB.ai. Okay, here it is. And then you need to log in basically. Let me just quickly go ahead and log in with the dummy account of mine. Let me quickly create the account. Here we are. We'll go to API keys, and we'll go ahead and create a new key. So I'll just say for YouTube, create API key. Let's copy the whole thing, paste it right over here, and hit enter. Okay. And now we just need to wait for a few seconds. Okay. If everything is done, we should be seeing a table with training loss and the number of steps. So let's wait. Okay. And as you can see, the steps and training loss is there. Okay. And as you can see, the process has been now started, right? So it's going to go through all those data set, and it's going to train the model so that the model can understand the pattern, the model can understand what exactly is going on, and you need to focus on this training loss, because the lower the value of the training loss is, the more better the model is understanding your context. But if it gets too much lower, in that case, instead of understanding the pattern, it's going to memorize everything. Okay, so we need to take care of this when you're dealing with your own data set. I have my data set, and I have prepared it in such a way that it's not going to happen. So I'll get back to you once this training gets completed, and after that we're going to use the model and see the difference by ourselves. Okay, so as you can see that the training has been completed right over here, and we are at a good loss. So if your value is below this 0.000500, it means that it has absolutely memorized your data instead of understanding the pattern. But fortunately, in our case, this is not the case, right? So this is where you need to understand about your data set, and you need to like play with it to know which data set is going to, and how you need to create your own data set so that you can have as much loss as possible, but at the same time it should not memorize your data at all. Okay, once you have this executed, you simply need to go ahead and click on this. We'll just see the remaining memory we have, so we are good. And now over here we can simply go ahead and call our prompt. Okay, call our tool. So we are importing the model, and let's try to go ahead and use the fine-tune model. So the model is fine-tuned, and we're going to use it. So we'll type find XSS payload for me. Okay, and I'm going to give it an input. So we are giving it the same structure on which it has been trained. So if you remember, it has been trained for the first, the user should give instruction. Second, it should give input. They should give input. And third, the output will be generated by themselves, by the model, right? So we'll just add the same payload, which was not getting perfect result. If you remember, for a equals to name is user input like this. Script tag close. Let's close the script tag and let's go ahead and execute this. If everything works, we should be getting a payload which should be absolutely working fine. Okay, let's enter. And as you can see, we have got this particular payload, which is absolutely right because this is the payload which is obviously 100% going to work in our scenario. Let's try to go to W3 school, okay, so that I can show you this payload is going to work 100%. So let's remove this first. Let's copy this whole damn thing, paste it here, okay, and we'll be replacing the user input with the payload that it gave us, which is this whole thing till here. We'll copy this and we'll simply swap this with this value and click on run. And as you can see, we are successfully getting alert 1, which confirms that the XSS is working. So you see, we are able to fine tune the model in such a way that it now understands about cross-site scripting way better than it was understanding before on the base model, right? We can also play with this more because we have like trained it with about 500 data sets. So it can do some really cool stuff as well. For example, we can give it like without using alert keyword. Okay, so let's say alert is blocked in our scenario or in some scenario. In that case, what's going to happen, right? So let's go ahead and click on play. And as you can see, it has given us another payload that we can use. And obviously this is going to work as well, right? This is how you can fine tune a local large language model on your specific data set so that you can make it very specific or very specialized for that domain specific task, right? So you can go ahead and play with this, try to create your own LLM for SQL injections and all those things. So, and obviously you can go ahead and use these models with your own set of other local language, large language models and try to create an agentic AI that can call this thing, right? Similar to what we have did in the previous video. So yeah, this is pretty much it. This is how we can actually fine tune a model, which is going to be specific for your use case, and it's going to work very, very, very well without any issues. And sometimes, for example, payloads like this, you will not see it on even on the frontier closed models directly because they are not trained on the specific data set, right? They are trained on more of a generalized and broader data set, right? So, if you have a good data set, what I meant to say is that if you have a good data set, even a low, small billion parameter large language model can even outperform some of the other open source and closed source models. Like I have tried this with GPT OSS and Quen 3, a very bigger model as well with more bigger parameters, but even they were unable to find a proper payload. But here with just 8 billion parameters, with that too, we have quantized it and we are still able to get way better results, right? So this is how you can use this. If you have any doubts, if you have any issues, just feel free to let me know your doubts or issues in the comment section. And now, with that being said, keep learning, keep hacking, and thank you so much for watching this video.